Right. As simple a device as the computer can be, it is actually a rather advanced device, because a lot of electronic devices, it will contain this thing. It's called the main circuit board, or otherwise known as main board. Some people call it the motherboard, some people call it the main circuit board, right? Any which way is okay. But technically speaking, if we're talking about a simplistic device, let's say for example a projector or TV remote, then the main circuit board is very straightforward. You have one thing, and that's that. You use that to control something or do something, and it's pretty straightforward. The computer is different, because the main circuit board or main board is this very flexible electronic circuit board. When we say electronic circuit board, that means it has lots of these little electronic components like transistors and resistors and integrated circuits, right? Transistors and diodes, integrated circuits, and etc. Right now, I'll just write down the full name for that: integrated circuits. Right? That means a host of different things, lots of this and maybe some of that, and we combine them together and we get integrated circuits, and then we put them on the motherboard. Right? So all of these small chips and components, and maybe transistors here and there, transistors and diodes and whatnot. Okay, now this is a main board, a very generic main board, because it has all of these different components. But a main board of the computer can be advanced, because with the computer you will have what we call the expansion slots. And the expansion slot is something that we can put more electronic circuit boards into. And because of that, the computer becomes a very flexible thing, flexible electronic device. Because on the main board or main circuit board, different things can be attached so that we achieve different kinds of results for the computer. Of course, the main things, such as the ones that we have learned in week 1, like for example storage, memory, microprocessor or CPU, these remain, meaning for the computer to function as a computer, you will need these different components. Right? But of course, we have different kinds of these components and different kind of main board that we can sort of mix and match, right? Meaning you can buy very advanced CPUs, lots of memory, and then a big storage, so you can store all of those movies and pictures and all the other things, assignment maybe, right? And put it on the main board or attach it to the main board. Some things, certain electronic components will be attached directly to the main circuit board. For example, transistors, diodes, integrated circuits. Some can be slotted in straight to the motherboard. The CPU, for example, will be slotted in straight to the motherboard. Memory slotted in straight to the motherboard. Storage is usually connected to the motherboard using what we call the data bus. Right, so these are the data bus. So it is basically these wires that help us send and receive data from the motherboard to storage and vice versa, right? So in week 1, when we draw all of these things like CPU and memory, right? And then we have storage. If you still remember from chapter 1, right? We have this diagram with arrows going to and fro, up and down, and then input, output, and whatnot. When we draw this diagram in chapter 1, right, in reality all of these arrows are actually pointing to the main board, which is the main circuit board that hosts all of these different electronic components and devices and helps sending of data to and from the different components we have attached to the computer, right? So that is the main circuit board or main board. Of course, because some devices, some components can be sensitive, so we put it inside what we call the system unit. Right? System unit. This is, in the case of a desktop computer, this is the box that a lot of people refer to as the CPU. Actually, the CPU is the processor, right? The box should be called the system unit. And system unit has different, I'll draw it here, maybe you can let's see. System unit has different form factor and footprint. You know what, because of the lighting and glare over here, which might make this harder to read, right? I'll erase some stuff and write it here maybe. Form factor. Okay. Footprint is basically how large or how small a system unit is. For example, a smartphone will have a very small footprint. A desktop computer will be significantly large because it takes up quite a bit of space, right? Form factor, on the other hand, denotes how the components, the orientation of the components inside the system unit. Meaning, say for example, in the case of a smartphone, the main board will be like this, and then all of the components will be slotted in somewhat like that. So all of the devices and components are parallel with the main board. For a desktop computer, on the other hand, a lot of desktop computers have the main board like this, right? And the components going like that. So it's perpendicular instead of parallel, right? So that is the form factor. How are the different kinds of components located and oriented in terms of in the system unit in connectivity with the main board, right? So that is the form factor. Okay, in your slides you will also notice a lot of things like connectors and ports and etc. Now we have a look at the motherboard again. Some components are connected using some kind of cables called the data bus. For example, storage devices like the hard disk drive and DVD-ROM drive and etc. They have some kind of data buses that connects it to the motherboard. Some are slotted in and some are integrated in, meaning it's bolted right into the system unit, which house all of these things. You will have ports. Like for example, a USB port or something, right? And on the ports, meaning or rather using the ports, you can connect these connectors. Meaning to say that you will have things such as the Ethernet port and whatnot, meaning these holes that you can put things in. And then you have the connectors, which enables connectivity between the part of the circuitry on the port and then part of the circuitry from the connecting devices or cables, right? Then you connect them together, so you get connectivity and you can interact with the main board. Now, on the main board as well, there are certain special ports and connectors where you will have to switch off your computer and put things in. These are otherwise known as the expansion slot, which we talked about earlier. Right, expansion slots. And then we have hot swapping type of ports. For example, we have the USB port. Right, so it enables hot swapping. What is a hot swapping? A hot swapping unlike the expansion slot that we have on the motherboard, where we have to switch off, realistically we have to switch off the computer and then crank open the system unit, then only we can put things in, right? So this is not hot swapping. Hot swapping is where you don't have to switch off your computer, right? With hot swapping, you can just connect your component, let's say for example USB thumb drive or mouse or anything. You just connect it straight to your port, meaning it gets connected straight to your main board. You don't have to switch on your computer, and that is hot swapping, right? Plug and play, on the other hand, is where you put it straight, and again you don't have to restart your computer, right? You just plug it in and immediately you can play it. You don't have to restart your computer, right? So you can say that these two are used rather interchangeably together, and usually when we say things such as the USB port, it has both of these capabilities: hot swapping as well as your Intel and AMD. All of these are brands of processors or central processing unit. In reality, the central processing unit is technically a computer on its own. I'll tell you what I mean. Computers have actually gone through four distinctive generations. Other people might argue that there's been more than that. Other people might argue that there's been less than that. But as far as the text that we are using for computing principles goes, we have four generations of computers. Four generations, right? The first generation is what we call the vacuum tube generation. Now, before we go any further to examine or look at vacuum tube, I need you to understand that at this particular time, or rather at that particular time, what happens with the computer is that it is a device that can compute. It calculates for you. And when we say calculate, it can do quite a lot of calculations quite fast. And that is a computer. And we need big computers, as big as factories, in order for us to do calculations, such as, let's say for example, square root of something, right? And so this whole vacuum tube thing is actually a combination of a lot of these vacuum tubes. Is actually just to do the work of one CPU, which in our case, in our time, is roughly 1.5 or 1 inch on each length. So this is a CPU, Intel or AMD. This is roughly the size is like this, 1.5 inch on each side. But back then, we need a computer as big as a factory. It's called a vacuum tube, meaning it uses vacuum tube to do the calculations that can now be done by this small little chip. And why and how? Basically, the vacuum tubes will have some kind of a lighting mechanism. So because of that, they tend to heat up a lot, right? And so they are much less reliable, right? This is to say that they consume a lot of power. They are very expensive, right? And they're not really reliable. So let's just put ability or reliability is not that high, meaning to say that they are prone to crashing because they overheat, right? Then people came up with the idea of transistors. This is the second generation of computers, right? And with the second generation, what happens is that they consume less power, because instead of heating up, meaning there are no lights or anything like that, right? So it does not heat up, and it becomes cheaper. It becomes smaller, right? So sorry, size is big as well. It becomes smaller with the transistors, because vacuum tube in general is bigger than transistors, right? as well, one transistor might be able to do the work of maybe 2 or 3 vacuum tubes, right? So the size becomes smaller, it becomes cheaper. Here we're talking about the computer the size of a room, maybe, right? You imagine LH7 or LH8 or LH6 if you're having your lectures over there, right? Or maybe one of your SRs. Okay, then people start thinking, hey, people become smarter, and they start combining all of these different little components called transistors, and now we have the integrated circuits. And this is the third generation of computers. And with the third generation of computers, with all of the transistors getting smaller and closer together on single chips like these, the computers become even smaller, right? Computing power increases because now we can do so much more on so little stuffs, right? The price gets lower as well, and ability goes up. And the size here, we're talking about maybe one filing cabinet, right? Around 5 foot tall, maybe 4 foot tall, right? And 1 foot or 2 feet width, and 2 feet width, and 1 foot depth, right? Something like that, right? Then people become even smarter using all of these different technologies and components and knowledge that they have. They now combine these and make it even smaller, and they are able to create chips called the CPU that can basically you have one chip which can do the work of several of these computers, right? So this is called the microcomputer, right? And so this is the era of the microprocessor, meaning to say that we actually have one electrical component that can do the works of one computer or several of these computers. Now this becomes a realistic proposition. Now this becomes the personal computer, meaning something that is, one, affordable enough so that people own them personally, and two, interesting enough because it can do so much more. You see, it's like, because one chip, or rather one part of the chip, can do so much things, right? It can do the work of several computers of the previous generation, right? And because of that, you have things such as multimedia. You can do multitasking, etc. So the computer becomes interesting, and the computer gets to our homes, and they're called personal computers because we can realistically own them, right? The cost is really low. The computing power increases. In fact, they use very little power. In fact, we have portable ones now, right? The ability increases because it's like one chip can do the work of several of these, right? The size becomes smaller as well. You might have it inside your back pocket now. It's called smartphone. And that is the generations of computers: 1, 2, 3, and 4. Vacuum tube, transistors, integrated circuits, and microprocessors.